right, hi everybody. We're just going to go through a little bit on how to do the nuclear decay worksheet. So the first part is asking us to identify the following nuclear decay equation as alpha, beta, or gamma decay. So let's start with number one. The easiest way to identify these is to look at the products or what comes after the arrow, and you can see that helium is a part of that. If you remember what alpha decay is the release of a helium atom, or two protons, two neutrons, no electrons. So if we ever see a helium atom, we know right away that the decay is alpha decay. Number two, again, we look right away to the right side of the arrow, and we see an electron, atomic mass of 0, charge of -1, or atomic number of -1, meaning it has a negative charge. Anytime we see an electron, we know right away that is beta. Anytime we see the helium atom, alpha decay. Anytime we see the electron, is beta decay. And then finally, we have our gamma decay. So we look to the right of the arrow on number 4 here. We see this weird looking Y, that is the Greek letter gamma. And that is a dead giveaway that this is gamma decay. So the symbols will tell you exactly what type of decay is going on, and then you can go through and do the rest of numbers 1 through 6. Moving on to number 7, complete the following nuclear decay equations by filling in the missing isotope symbols. So moving along, we know that this is beta decay because we see the electron there. So if we take the two numbers on top here, 0 and the 40, what's 0 plus 40? We get an answer of 40. And then we take the two numbers on the bottom, -1 plus 20, we get an answer of 19. Because an isotope symbol has the atomic number on the bottom, we just look to our periodic table. We see the atom that has an atomic number of 19. We see potassium. So our answer is potassium. Number 8, we see the helium atom, which is a dead giveaway that it is alpha decay. And again, we're going to add the numbers on top together to find our product, or excuse me, our reactant. And we're going to add the numbers on the bottom to find our atomic number. So let's start on top. 226 plus 4 is 230, and 2 plus 88 is 90. And if you look on your periodic table, thorium, right? Now, here it asks you, is the equation balanced? Yes, it better be. If it's not balanced, we did it wrong, right? So all of these at the end should say yes. If they don't, if the equations don't balance, then we got bigger problems. Moving on to number 13, write the equations for the following nuclear decay process. So we're going to go through the alpha decay of radon 198. So radon has an atomic number of 86. So what we're going to do, we're going to put its atomic symbol, Rn, 86 down at the bottom, which is its atomic number. And then the 198 tells us that is our atomic mass. And it says right away it's going to go through alpha decay. And alpha decay is characterized by that helium atom, which has an atomic number of 2 and an atomic mass of 4. So we can think of this kind of like an equal sign. So 86 equals 2 plus what number? Right? You get number 84. And then 198 equals 4 plus what number? Right? We know right away 194. And then all we have to do is look to our periodic table. See that the atomic number for 84 is polonium. And again, the equation is balanced. If it's not, something should be wrong, right? So we have 2 plus 4 is 86, which equals our radon. And then 4 plus 90, 194. 198 equals our radon. We know the equation is balanced. Just a little head start on the next one. I'm not going to do it for you, but again, the beta decay of uranium-237. A little head start on that one. I'll do number 15 with you, and then I'm going to have you guys do number 16 on your own. That's going to be one of your problems for your homework. So write an equation showing the product form when practium 229 goes through 2 alpha decays. So we're going to start with PA 229. And when we look at our periodic table, PA has an atomic number of 91. And we know that it's going to go through 2 alpha decays. So we're going to get an alpha particle, which is a helium atom, after each alpha decay. We can throw that in there, kind of cheat. Go ahead. And then 91 equals 2 plus 89. Let's make that a little bit smaller. And 4 plus what equals 229? Well, we know that's 225. If we look at our table, our periodic table of elements, see that number 89 is actinium, AC. Now that product right here is going to go through another alpha decay. So we have 225 equals 4 plus what number? 221. And 89 equals 2 plus what number? 87. We look on our periodic table of elements, we have francium. Oops, sorry about that. And there's our answer. Right? I'll help you get started on the next one, number 16. Again, we start with an alpha decay. We go through a second alpha decay. And then we go through a beta decay. Then we go through another alpha decay. All right, and then your final answer will be right here. All right, don't forget to call, email, FaceTime, or not FaceTime, but Google Hangout, Zoom, whatever your teacher's using if you have questions. Good luck, everybody.